Welcome back to the stream, everyone. It's always nice to hang out and do electronics with cats. In particular, we have this guy looking absolutely amazing today. A lot of you are probably Tuco fans, but if you're new here, this is my cat Tuco. He's pretty adorable. So this series of streams has been about a project that I'm doing to help more people on the internet hang out with this adorable little dude. It's also an excuse to learn some new tools, and it's also, an attempt at maybe making some reusable robot infrastructure bits that people can cobble together in different ways. But it's mostly a way to help people hang out with my cat. And for the last couple weeks, we've had 2 additional cats here. I've been looking after 2 cats, a little black girl cat, Luna, and this huge puffy dude named Cloud, who looks a little bit like Tuco. And so you'll see them around also. So, on today's stream, I wanted to get started with just going over some of the new kind of software bits that I've been working on for the robot. But then I think we could dig into actually fabricating a little bit, because this robot is very close to done, or at least the first one of them, and then I've just got to build a few copies, which building the second and third and fourth is always going to be easier than building the first. So this is what we got so far. This is the winchbot. That camera should probably be recording. Yeah, let's see if I can control this. So it's a robot. It attaches to the wall. It moves things around. A single winchbot can move something around in 1 dimension. 2 winchbots can move things around in 2 dimensions. 3 winchbots, 3 dimensions. Sadly, with 4 winchbots, which is the plan for this project, well, no 4 spatial dimension movement. Of course you get time, but that's pretty pedestrian. We're only a few minutes into the stream, and I already called time travel pedestrian, so I guess we're going all right. Anyway, so one of the things that I spent some time doing the last couple days with the software was doing some UI and infrastructure work to support changing parameters, like changing the PID loop tuning, and now I have calibration to add to that so that I can actually get the sensor data from the winches. So each winch has a position sensor for measuring how far the cord's traveled, which it uses for closed loop feedback, just for motor speed control, not for like accurately predicting the position of the robot, because that would require taking into account a lot of other factors like cord stretch and the pulley geometry. But the bot itself still wants to know how fast the cord is actually entering or exiting itself, and just in order to keep its own control loop tight. So it's got a sensor for that, and we need to calibrate exactly how many counts on that sensor correspond to whatever distance, which could change a little bit depending on kind of how much the cord tends to squish as it goes through the system, and the exact diameter that the capstans are fabricated at, things like that. So I have an option to calibrate that. And then the force sensor definitely needs to be calibrated, because that's just like a completely meaningless 24-bit number coming back from the A to D sensor until you actually convert that into something. And it would be more correct to convert it into an actual force unit like newtons, but since mostly we're going to want to be equating this to the forces we experience while picking up a particular load under Earth's gravity, I've been representing force as a kilogram force. So basically how much things weigh. It's like what a scale would read, but it's actually technically a measure of force rather than weight. So let's take a look at the UI so far. The PID loop, I kind of started to get it tuned in, and then when I added the calibration feature, all the units changed. And so rather than just taking the PID loop parameters I had before and carefully converting them to new units, I figured I'd just tune it again. So right now the tuning is not so great. It's a little bit sluggish. Anyway, let's take a look at what we've got. We really need to devote as much screen space as possible to that cat, though, because he is amazing right now. All right. So we've got a server here that runs on the PC that talk. So the robot is kind of a distributed system. Each winch is sort of its own self-contained robot, but then the Tuco Flyer robot as a whole is comprised of actually 5 separate robots and a PC that are all talking to each other. And a train, but the train isn't on the network, as far as I know. Might have to secure my Wi-Fi. Yeah, somebody on the train hacked the winch. Yeah, so the central controller here is what I've been working on the most lately. It's written in Rust. It's running on the Windows machine that's doing the streaming, just because that's a convenient place to put it, but it could be running pretty much anywhere on the network, as long as it also has access to the separate network that the robots are connected to. Because that's like a totally physically separate network that's only connected to the robots and to this machine. And when you start it up, it gives you a URL, which includes this kind of secret key, which obviously I'm sharing with all of you, but it's only really useful if you're on my LAN. And this is used to very simply kind of challenge response, authenticate with the server so that we can log in a way that isn't completely insecure without actually having to go through the trouble of sharing SSL certificates with anybody who wants to connect to this on my local network, or like forcing somebody to register a DNS just to play with my robot server. So, oh yeah, and Mikey is mentioning the clickety-click tension sounds. So actually, some of that is from the tension of the, some of that is from the rope slipping on the spool as it winds, which isn't really a thing I can solve. But some of that I'm actually going to look at and maybe be able to solve next time I have it open. Since I think one thing that started happening is that one of the vertical rollers, the bearings in there are a little bit loose in their sockets, and so I think they've been kind of creaking a little bit as that roller moves. So next time I have a chance to look at the physicality of the thing, I'll test that theory and see if I can fix it. It's just lately I've been focusing on the software, and so I've just been trying to not go on too many tangents all at once, because switching between the software and the hardware side is a little more heavyweight than just working on different parts of the software. At least the way I've been approaching this. So anyway, I've got this little configuration UI. So you'll notice it's authenticated. I've got a little bit of just like graphing ability, so I can take a look at the sensor data coming from the central flyer. So like this is just a microcontroller with some analog inputs that aren't connected to anything really. But where I've mostly been working on actual usable UI here is on the winch pages. So you can select one of the bots, and you can actually just drive it around on the website. And I also have a Xbox controller here that can do basically the same thing. And we can look at the sensors. So this is the force data. The kind of light gray line is the highest resolution data we have that's coming right from the HX711 amplifier at 80 samples per second. Oh, I just noticed Peter's comment that says the Twitch stream seems to be offline. Yeah, I guess you're right. Let me see if I can fix that really quick. Well, I don't know if I actually have the ability to super debug that right now, but I can at least restart my streaming here, which should just result in a very momentary glitch on YouTube. It'll treat it as the same stream, but it'll give this a new chance to connect to Twitch, so I'm gonna give that a shot. Bear with me for a sec. All right. We're back from a brief interruption, which is hopefully what everyone is experiencing this as. I was just restarting my broadcast really quick to see if I could bring Twitch online, since it looks like only YouTube was working so far. And it looks like Twitch is still offline. YouTube seems to be back. Oh, that's frustrating. Yeah, I mean, I guess I could SSH into the stream machine and debug this right now. Oh yeah, that's a good sign. What's going on there? Should I just reboot this machine? Last time this happened, the problem was like a kernel update went bad and then the transcode on this machine was failing. I'm a little wary about going deep into debugging this on stream, since it would be easy for me to inadvertently expose a stream key or something like that. So I think I'm probably just going to have to deal with this stream not having a Twitch mirror. Sorry about that. Hopefully that'll be our glitch for the mission. Alright, well, we're here on the YouTubes. Let me at least bring that back to the front so I can watch the chat there. Okay, so I tried to bring this a little closer so maybe I can demonstrate this without going completely off mic. Yeah, okay. So we have a roughly calibrated force sensor now. You can see this is in kilograms of force, and in this particular view it's kind of hard to see the current value, but you can at least see maybe the numbers at the top and bottom of the graph showing the current scale. And in fact, if I just wanted to grab the current values, so I've got these tabs that are specific to parts of the bot, like this is going to be for the more flyer stuff. Right now it's pretty sparse. This is like for each winch. But I also have this net section, which is kind of about the network communication between the client and this particular server. So there's a console where I can just give it random JSON commands and it can complain at me. There's also this model where I can see the JSON. So actually this isn't internally JSON. This bot doesn't actually run on JSON, but it's built with a bunch of Rust data structures that Rust can serialize, or rather the SERD JSON crate in Rust, like it can generate code that efficiently serializes all the data structures that I've described, which in a lot of cases actually match the data structures the microcontroller is using. And it can actually just take all of that strongly typed stuff that I've described in Rust and in C and convert that into JSON so I can deal with it in the web without having to repeat myself all over the place, which is super nice. Like this JSON structure here, the one that says flyer sensors, this is literally just the same as a UDP packet that's coming into Rust. We just know how to decode it in Rust, and then we know how to re-encode that as JSON. So here, yeah, actually, I was going to say, well, we could just look at the force here, but this is all pre-calibration, so I might want to add a view to that sensors page that shows the current calibrated force value. So at a low level, this model is what we're actually dealing with. So this message thing is what actually comes from the robot. So, or rather, it's kind of a wrapper around it. We're saying that we got this thing from winch 0, here's the thing, and the stuff inside, I can't highlight this when it's constantly changing, but is there any good solution to that? And the mouse cursor is kind of invisible here. Anyway, I guess it's not too bad if I don't put the cursor on the text, it's the arrow, which is at least kind of visible. So starting from this line and down to like that line is the UDP packet that we're getting from the winch. So it's got a counter indicating like how many commands it's received, how many times its control loop is run. This is the last thing that it got from the central control computer. So every time we send it a packet, we just give it a new set of commands indicating here's the velocity we want you to reach, here's the maximum acceleration you should use, here's the minimum and maximum force readings that you're allowed to move under. So, oh yeah, Mikey says so much potential for the Tuco Flyer and other applications, 3D positionable lighting, microphones. Yeah, I was thinking about that too. Like, I wonder what because it's one of those things where I'm actually going to have to start putting some of these thoughts into a more cohesive framework ASAP, because I really want to start like actually cranking out some more videos about this project. I feel like I've been kind of trying to rush to get to the point where I've actually got the winch working, and it's so close. Like, the one thing I want to do to it still is to add some interior lighting, which I think I'm going to try to get to on this stream. But yeah, then I would just want to start cranking out some videos with details about the specific parts of this project, including why did I have to build this in the first place? So I was looking at other solutions, like, there's a handful of other kind of DIY, kind of wire-driven robots out there. Pretty much all of them use stepper motors, and it seemed like, well, pretty much all of them use stepper motors, and they required these kind of big, like, counterweight systems. There were a lot of moving parts and exposed steel cables and things like that. Oh, Electrodoom suggests a CSS hover. That's a great idea. I should probably fix that. Yeah, I could just fix that, because this is my website. I could also maybe use a different theme. This is just one of the built-in themes from the React component that I happened to grab for styling JSON. So yeah, I saw a handful of other projects that would do similar things, but they weren't really the kind of thing that I would just want to leave deployed in my shop around a bunch of cats and kind of visitors that might have curious fingers, and it didn't seem like something that would be like a thing I could live around continuously. It seemed like a thing that I could just like set up for an installation. So that was what led me to a lot of the design decisions. I wanted to make something where the actual kind of moving parts and high voltage and all that were pretty self-contained, and all the parts that were kind of exposed in the shop were subject to some amount of safety consideration. So like the force sensor is a big part of that. I didn't want it to move if something got jammed. And then just like with stepper motors, unless you're using just super high power components, you usually can't move them that fast. Usually there's this very static trade-off where you have to kind of choose how much energy you're putting into the motor, and well, that's how much torque you get. Whereas with something like this, it makes sense for there to be a more dynamic trade-off there. I'm not trying to precisely move this thing within a certain path in space. I'm just trying to give people who want to play with my cat a good cinematic experience. But when you take this and apply it to other areas of design, like somebody I talked to was interested in something like this for like interactive stage shows and that kind of thing, like moving around props. And yeah, I can imagine a system like this for that. And it also makes me wonder, like, well, what is there already for that kind of environment? And people make remote control winches. One of the things I looked into was using just an automotive winch. But the two problems I saw there were that they were not easy to enclose. They were kind of these big, kind of oddly shaped things that wouldn't on their own be safe. I'd have to add all these safety features to them still. And then they also were just geared to move really slowly and pick up really heavy loads. And I'm not interested in moving like 1,000 pounds super slowly. I'm interested in moving, a couple of kilograms at a rate that is visually interesting to people. So not like super, super fast, but not pokey. So that was what led me to this. And so maybe that'll be interesting for other applications too. Yeah, and I guess, as Microhacks points out, wire-driven cameras, like, those exist already. And yeah, they exist. I just couldn't find one that fit my requirements. They exist for sporting installations where, they're all super high power, but also really far away from people. And they exist, in these kind of like super researchy, prototypey kind of makery things that don't necessarily have the characteristics I want either. So this is kind of just throwing my hat into that design space and seeing if I can make something that is more suited to this kind of a thing. So back to this. This is the packet that I'm getting from the robot, but there's also this thing labeled config, and this is a lot of what I was adding just in the last day or two. So this is something that you can monitor in JavaScript pretty easily. I added some infrastructure for listening to configuration changes and getting the initial configuration and stuff like that. But I was trying to keep this thing simple and not build this whole complicated publish-subscribe infrastructure for something which is essentially very low bandwidth and only really changes when I'm messing with the configuration or manually moving the bot around. So there's actually a decent amount of stuff in here that would change not that infrequently. Best example is, I think, the mode for the bot. I have this concept of kind of an overall control mode. Like, is it completely automatic and controlled by anyone on YouTube, for example, versus am I, on the other end of the spectrum, just moving around a single winch for debug purposes and want to lock out everything else? So, for example, if I press some of these buttons on the control pad, right now the mode goes to halted, or manual flyer, which I'm imagining would be like manual control over the three-dimensional camera, or in this case, manual control over just one winch. You'll also notice that it says saving configuration over here. So the configuration, I wanted it to be persistent. Do I have a shell on that computer? So I wanted the data model to be something which was roughly JSON compatible so that it would fit in with the web interface pretty nicely. I was going to try to use TOML because that's a nice sort of easy to edit as text kind of format that Rust already uses for cargo configuration files, which are like its make files. But then I ran into some limitations where it has trouble representing Rust enumeration types. So like, for example, this mode where I can be manually controlling a particular winch. It's not just a textual enum like this where it's like halted or manual. It's an enum that has some data associated with it, and TOML apparently can't represent those. So I ended up picking a different format, which is roughly JSON, but more human-friendly. And in this case, I'm using YAML. Oh, can I not run bash from SSH? Right, I ran into this problem before, whatever. Right. So this actually, I should just open this up in Sublime Text. Users. I don't think I still have that computer mounted. Okay, there we go. I'm still having this problem with the keyboard USB connection. Okay, now we've got a local text editor, which should be nicer. I'm also going to take the camera view down for a sec. So that's a good question from Mike, who says, or observation, I guess, who says, controlling this thing via people, mouse, and keyboards with a ping delay is going to be interesting. That's why the control scheme I expect to have on the other end of the ultimate kind of web-based interface is going to be higher level than this and based in part on computer vision. So I'm imagining that, well, I've actually got two answers for that. One answer is I'm hoping that using services like letsrobot.tv will help me have lower latency control. Because that's a pretty exciting service that is, you know, it's basically like Let's Robot was a project that was using Twitch to, you know, like control robots over chat with a live stream, similar to what we're planning on doing here. And they had trouble with Twitch in terms of service stuff, but also in terms of just having way too much latency. So they're working on a completely new platform that's designed specifically for low latency and robots with like client-side UIs. So that's actually pretty exciting. I'm interested in integrating with that. So that might allow some more direct control. But I think regardless of the latency level, but especially if there's high latency, it would be nice to have some way for the camera to semi-automatically track things that are in its field of view. So instead of just saying move left, you could say move like my area of interest left. And there could be like some way of foveating the vision. So like I don't want it to be like a crosshair necessarily, because that seems a little violent, but maybe if there's like a circle or something, or like, you know, maybe some kind of pattern that indicates like this is what the robot is interested in, and you can control that with chat commands. I think that would be a good compromise that lets some of the like twitchy control happen with a computer here locally. Oh, VR mode would be interesting too. Yeah, that would be pretty cool. Yeah, that'd be a good excuse to also throw a 360 camera on this robot, maybe. I think those are probably, it's probably getting easy enough to find 360 cameras that are not super heavy now, right? And Fred says, I think it has a depth sensor. I'm planning on putting a depth sensor somewhere, but I don't think that's going to go on the flyer itself. But yeah, I think the overall architecture for this kind of grand sprawling vision, which I'm trying to break into manageable pieces, the first thing is just get a movable camera online. But if that works out nicely and seems like a good idea, then I can imagine a lot of additional things. Like we've wanted to have both a depth camera and a thermal camera that are just overlooking the space. and kind of have a mini-map view showing where the robot is and where the cats are potentially. And then also, of course, having robots that throw things like Tuco, and even one of the temporary cats, Cloud, is really interested in playing with plastic bolts. So having a way to like chuck bolts and interact with the cats, that would be great. I also just recently got an overhead camera set up, which, check that out. Oh, I think we can shut this off too. How about that? So there's a little bit of a delay on here. Actually quite a lot of a delay, but you can at least kind of see the scale of this thing moving stuff around. That might have been better with the camera on there, because at least this camera doesn't have the delay. So that may be useful later. It is a nice view. Yeah, so that's basically the view from the railing on the loft above this space where I live. And that would be where I'd probably stick the thermal camera as well. Can maybe even angle that down a little bit so I'm not just viewing the windows. The cats hang out near the windows sometimes, but you know, they're not that tall. So I think let's go back to this view. Right, the YAML, which is such a weird name. It sounds like something I would have for lunch. And I guess there are some trailing spaces which Sublime Text is telling me about. Oh, can I disable that plugin? I don't really care that much. Anyway, usually I care about trailing spaces. It's just like this is an automatically generated file, so it would be nice to just have it shut up about those. I mean, you can edit it by hand, but it'll be resaved by, like, you don't want to edit it while the server's running because it's just going to save it anytime there's a config change. So it does this on a delay. So if I make a change here, you can see on the left, the website updates immediately when I press the button on the controller. But the saves to disk are rate limited at 1 per second. So if I press the button, then it's going to save to disk a second later. But if I just keep like mashing on the buttons, then it'll save it to disk once per second, which seemed like a decent way to do it. And then, yeah, this doesn't, I don't think this is just going to watch the file because it's over a network share, but if I force this to update. So then, inside this config structure, that's where I ended up just putting both, I mean, like really anything that's not kind of a runtime parameter that's generated by the robot. So something that I might want to edit in the UI, but also stuff that I'm just setting before the server really gets going, like these network addresses. I was thinking about maybe separating them into kind of different tiers of configuration, but it didn't really seem like that made sense because, you know, then I would need like parallel arrays of winches. So there'd be like a data structure that has, here's like one kind of configuration, and then inside there an array of winches, and then here's a different kind of configuration and an array of winches. And I just didn't like that. It seemed better to just have it all be more just kind of semantically one tree, and then to just kind of send out new versions of that entire tree. So Mikey is asking why I haven't taken the RD globe out of its crate and hung it up. One answer to that is I don't really like it that much. Another answer for that is that it's pretty hard to hang, and I'm not really sure where to put it. But yeah, I probably should put it up. Right now I'm just using the crate as a counterweight to keep the winch on the ground. But when I say I don't like it that much, I mean, it doesn't necessarily mean like I want to get rid of it or anything. I think it means I want to like work on it to improve it and make it better before I actually want to hang it up. Right now, like, I don't know, it's not that bad. It's I'm having the other like meta realization that it's really not helpful when artists are like down on their own work, because it's, I don't know, it never actually seems to help. It's just a feeling that happens. Yeah, there are plenty of projects. I've been thinking about doing more stuff with LEDs. I mean, maybe we'll start by putting LEDs in the winches, if I can get past some of the exposition here. This has been full of a lot of tangents, but maybe that's fine. Some people seem to like to just hear me go on tangents. So, this is really what we're here for. Within each winch, there's some stuff that probably isn't going to really change, like the network address. But then we've got XYZ location, which, I'm not going to be moving the winches around while the robot's operating, but maybe we want to calibrate the position while it's operating, so I could see that maybe changing. These calibration values are really mappings between physical quantities with regular SI units and the kind of hardware-specific values that we're getting from the particular winch. So they'll be similar on each winch because they're all using similar pieces of hardware, but they might be slightly different. I would especially expect the force sensors to have some variation. Probably a lot of variation on the force sensors. Those are just like very, very sensitive, and so any little manufacturing variation is just going to change the reading completely. Whereas the distance sensors, I would expect these calibration values to all be pretty similar. But those are all like 3D printed parts that'll have slight variations. Yeah, so Mikey brings up a good point, LED warning light so you don't walk into it. Well, I don't know if you were talking about the orb art piece thing, which I'm like kind of standing in front of, or the winch, but the winches are going to have lights, I think, to be pretty useful. Like, honestly, part of the reason I'm adding the lights now is not just to look good, but because I actually would find them useful for working on the system at this point. I wanted to have the lights show the kind of mode on the system, things like, is it experiencing a fault for some reason? Am I controlling it directly? Is it in automatic mode? And then if it's kind of running normally, then they could just kind of light in an interesting pattern. Like they could be, they could just kind of like subtly move up or down as the winch moves, and then kind of stay dim when the winch is like idle and not moving around, something like that. I'm sure the cats will appreciate that. The two new cats, the temporary cats, Luna and Cloud, have been super interested in that winch. So I've got all that low-level data. I've been trying to start assembling it into a higher-level UI. So right now I've got this force feedback, which is actually in kilograms finally. So if I just pull this completely slack, you see it pretty much goes to 0. You also see it went below that red line, which is my current force minimum. So if it's below there, the winch will refuse to go any further down. So I can actually demonstrate that with the camera. So let's put this back in manual mode. So I'm just going to run this until it touches the ground, and it just stops. And then run it back up. You can see it just briefly. So I have the force limits actually set pretty narrow right now. You could set them a good bit wider and still have a useful response. Oh, this is confusing. So imagine something terrible was about to happen. Like, this might get stuck and like start to destroy itself or start to pull things over, and it just automatically stops. I'm not quite bold enough to like ram it into that end stop because I haven't tested how fast it stops, especially not with a barely tuned PID loop, but the basic idea is that it should be possible to have this tuned so that it can stop when an error happens pretty abruptly, if it needs to. But otherwise, it shouldn't, it shouldn't get above or below those force limits. Whoa. I think I just switched the camera into photo taking mode. Good job, Micah. I hope it didn't corrupt the file trying to do that. See how much confidence I have in these cameras and their SD cards. Yeah, and then we have this other graph with velocity. So I've explained this a little bit in earlier streams, but we've got this one line that moves right away when I tweak the joystick. And so that's the command that we're actually giving the winch bot. And then internally, it's going to actually ramp up its own velocity in order to enforce a maximum acceleration limit. And that has a few reasons. That's just generally nice to the mechanical parts to keep the acceleration low. It also keeps the cord from getting bunched up anywhere due to moving really fast. It also keeps the motor from just dumping a bunch of extra energy into the power supply and triggering its overvoltage reset. And so when the limit kicks in, it immediately starts acting as if the target is 0 and ramping down. But then if the control loop doesn't actually kill the power to the motor within a fairly short timeout, I think it's like a quarter of a second right now, then it'll just turn off the H bridge and then the motor coasts to a stop. So then inside here, there's some parameters we can edit. So there's a maximum acceleration rate, which is that ramp rate I was just talking about. This is the maximum velocity that we'll try to tell the control loop to reach when the stick is in its maximum position. So it's really just about this manual control mode. There's the minimum and maximum force values. And this is actually how quickly the force limits track the actual force that's coming in. So you can see here, we can just put a really deep low-pass filter on there. And then it kind of takes that a while to settle, like a digital scale would usually. So you wouldn't want that normally, but we'll use that for calibration. Normally you would want this to avoid just picking up every single seismic vibration, but still react pretty quickly if there's a fault condition. Of course, we need to get this back into scaled range. Yeah, so this is, you can see that like this sine wave is the thing swinging back and forth on the cord. But like if I were to just like stomp the ground, then you're going to want to filter out most of that, which this is accomplishing. So we've got that. Still got that annoying timing check screen from before, but I put it a little bit deeper in the UI. Got a PID loop screen. So we can see some kind of classic PID loop going on now. So at the top is the velocity error, which is the velocity that we're commanding after it's gone through that acceleration ramp filter, minus the velocity we're measuring. And so it's going to be pretty noisy because that's, like the raw velocity measurement is going to just naturally have a lot of noise because we're taking these periodic samples and just subtracting those. And so all the quantization error of things kind of falling into, you know, this many counts on the encoder or that many counts, all of that just on a kind of control loop tick to control loop tick basis is going to be pretty jittery. But this entire control loop is a filter, basically. We're taking all of these inputs, multiplying them by gains, and then summing them into this output that persists from cycle to cycle, which is this PWM command. So the filter itself is effectively a low-pass filter. So I didn't see a reason to add an extra filter on top of this input. It looks noisy in this pane because it is. So yeah, got this kind of noisy, but this really tells you how good the control loop is at reaching its target. Like if this doesn't converge to 0, then it means like it's trying to go, but it just doesn't have the power, you know. But if it converges to 0, then it's doing all right. And if it oscillates wildly, then there's a problem and some gains are too high. And so we can also see the error derivative and the error integral. The derivative, and so, you know, these are just the derivative from cycle to cycle and the integral. So right now, with only proportional gain, so let's take the rabbit out of the hat and show the gains here. I put all these sliders behind buttons because I just didn't want to like accidentally change the configuration of the robots all the time. but if you just click that, it just shows this, and you can edit the gains. And these are in that config tree, just like everything else. And the units on here are, I mean, people usually think of these as unitless because the units are usually pretty weird. This is sort of in motor PWM units, which just go from -1 to 1 per, in this case for the proportional gain, it's motor PWM on the numerator side over velocity error, so meters per second. So this would be seconds per meter, I guess. And this would be the same thing, but with the, the integral and then with the derivative. So these are really just the inverse units of this, if you assume that the PWM command is unitless. So yeah, let's start with all of these to 0, 0. If we had no gains whatsoever, then here I'm commanding it, and you can see the velocity error. Since we're not moving, this is just showing us what the velocity command is. So you can see the ramp rate that we set on the other page. And this is nice because it's good at ignoring just physically impossible requests. Like, I want you to go from 0 to as fast as possible immediately, because that'll just cause the PID loop to oscillate. And also, as I said, it ends up, if you decelerate really fast, you end up dumping a bunch of energy into the motor controller, and I'd like to limit that just to be nice to the power supply. So that's after the ramp. And the integral, as you can see, just gets really high, kind of arbitrarily. And normally there would actually be a watchdog timer that would cut in and just reset this to 0 if the commanded velocity is 0, but the motor is still moving. So in fact, we could trigger that if we wanted by letting off on the control stick, so we're commanding a 0, and then if the winch thinks it's moving, it'll just 0 all those counters after a quarter second. So if I can cause some motion. Did I lie to you? Why isn't this working? It might be that it has to be on a bunch of consecutive ticks, so if it ever, yeah, it has to be continuously moving for a quarter second, which I don't think I can do just with tension like this. Yeah, I don't want to like backdrive the motor right now, because that would probably involve putting a bunch of strain on the other parts. Okay, so I can't really demonstrate that right now. But if I start to nudge up on the proportional gain right now, then actually, right now, if I nudge up on the integral gain, then it'll start dumping this into the PWM, which will briefly move the motor, and then the watchdog will kick in. Let's try that. Yeah, okay, that worked. So now let's try proportional only. So let's start out really low. That is pretty sensitive still. So you can see velocity error ramps up, and then slowly that translates into the PWM command ramping up until we start to reach the velocity we're aiming for, and then that levels off. And you might also notice that the velocity error integral and the PWM command look pretty much identical. They're scaled differently, but they're both integrals of the velocity error times the proportional gain. Regenerative braking. Yeah, I mean, it does have regenerative braking, actually. It's just the energy all goes into a capacitor, and it can't actually store that much, so at some point the power supply overvoltage protection kicks in and turns off the whole works. Oh, that's a good question from Mikey, who asks, do you think you'd have the same knowledge you have now if you hadn't worked in the big corps in the past? Did you learn a lot with them, or were they limiting? Kind of neither. I mean, like, I kind of had this approach to just kind of diving into stuff and learning it before. Like, that's how I got the jobs in the big corps. That wasn't really something I learned there. So, I mean, and it wasn't so much limiting in that way. It wasn't like I couldn't learn stuff there. It was just that it really competes for your time, especially, depending on where you work for. So, yeah, I don't know. You see people with a lot of different strategies for learning things. It's super helpful, at least for me and, for, I think, people who share my learning style, to find something that's just really interesting and then have the time to just dig into that. But like having that much time is kind of hard to come by, and like it worked out for me because I did a lot of it in my childhood when I didn't really have anything better to do. But if you're doing it later in life when you have to balance a lot of other adult responsibilities, then yeah, I mean, I think it can be really helpful to have somebody to work for who at least will kind of give you a place to learn stuff and doesn't hold you back from it. So like if they help you like at least work on stuff that lets you push your own boundaries, and then they don't like kind of stifle you in other ways. So like I worry a lot about companies that really try to like own everything you produce and don't like you to have the time and mental space for side projects. I also don't like companies that are like, mandatory side project culture. Like, it's nice to have somebody to work for who actually understands that life shouldn't be entirely about what they want you to do. And that's really hard to find in big companies because they just don't care. So we can do something about this velocity error integral staying high. So the integral gain is actually specifically, as you might imagine, to combat this thing where, we're working pretty hard to kind of adjust this PWM command to get the velocity we want. But there's actually kind of a balancing point that it reaches where, we've reached the PWM command that we're going to reach, but there's still this remaining error. And so if we actually track that and then specifically multiply a gain by that and add it, we can actually cancel that out. And then the way that actually ends up affecting the motion in practice is that, especially right when you're first getting going, it seems like it's good at taking that cumulative error of, well, we're adding energy to the motor and it still isn't even moving, and it can kind of sum that together into a little pulse of energy when you get started. These parameters have a lot of different, like the tuning of these things seems to be something that, like, a lot of work goes into, and some of that work takes the form of like very, very mathy research, and some of it is like sticking your finger to the wind and claiming it's black magic. And I think maybe both strategies work, but so you can see right there the shape of the velocity error integral and the PWM command were different. Like this was definitely decreasing over time, but it didn't really look like that helped that much. So let's give it some more. Oh, that time it just overshoots. That's way too much. Okay, maybe that's just too much integral gain. Maybe we need more proportional gain. I think my strategy for these are usually to start out with only proportional gain, and then to tune this to the point where it is reliably not unstable. So like right here, it's pretty sluggish. But let me see if I can give you an example of it being unstable without risking breaking anything. Oh, that's still not quite unstable. Let's go a little further. How much can we give it? Oh yeah, that's oscillating. So yeah, we don't want that. And it could be a lot worse than that. Like it can just go into super chattery, rapid oscillations too. Yeah, Electronoob says, I look forward to the elimination of the creaking. Me too. Okay. So yeah, kind of just trying to reduce the oscillations there. That is annoying when there's a web browser hiccup. That is one reason it's nice to have a controller that doesn't involve going through a web browser. Yeah, the creaking certainly gets the cat's attentions too, and they just want to know what little creature is inside making that noise. So also these parameters just go to the file pretty much immediately, so you can easily just use git to diff them, which I've been enjoying. Yeah, and I'm really looking forward to having more of these winches. Like after I get the lights put in this winch, that's my next thing, is I just need to like build these things. And I might be streaming that tomorrow morning. And this is nicer. This is feeling more responsive. This velocity error integral levels out faster. This might be an alright place to leave it for a little while. We can maybe do more tuning later, but let's see if we can add any derivative gain. Let's see if that helps. Ooh, that's bad. I might need a different scale on that slider. Oh, that's a good question from Mikey, who asks how many hours of printing so far, I think. I mean, it's really close to done, actually, so now I'm thinking, like, oh, how many total is it? I mean, I think each winch is about 4 days of printing. So, yeah, like basically 2 weeks of printing for this whole project. Maybe a little more than that, because, yeah, of reworks and reprints and things. And that's mostly just done on one printer. Like, I have a little Orion printer that I use for the small parts, but the things that really take a lot of time to print, I've all been doing on my Type A. Can't quite tell what the derivative gain is doing. Let me just see what scale I should be giving this. Because that's way too high. Let's set the limit on this to like 0.02. So for that, let's actually switch to the debug web UI here. So the Rust server runs the web UI on port 8080 by default, but I can also use the React development server on port 3000. And then, so that I can do this with the authentication, what I actually want to do is grab this URL with the token in it, and then paste it in here, but change the port to 3000. Cool. Right, and so that would be over here. I guess I don't have the highlight trailing spaces plugin in my other computer I'm editing this on. Why is that write protected? I guess I have the network share mounted as the wrong user. Yeah, that is the read-only user. I should be mounting this as me. Sorry for the delay. Let's have a... I was going to show you a cat while I typed in my password. Where did all the cats go? How are all the cats missing? Maybe they're all upstairs. Okay, well maybe I can't give you a cat easily. Maybe I'll just put this on my lap. Yeah. Oh yeah, my printer does keep, like Octoprint keeps a bunch of information about the printers. I'd just have to like write a script to go through it probably. Oh, actually, I should show you the time lapse from the last print because it's pretty cool. It's worth sharing. Where should I put that? Yeah. Yeah, this is what I want. Yeah, so this is one of the WinchBot shells. Maybe let's switch to full screen so you can get the timer on the corner too, because that's kind of interesting. So yeah, each WinchBot shell is about a day-long print. I might be able to make it go faster, but I had a lot of problems with misprints on this, with stuff just... Because like a print that's this big, reliability is kind of more important than speed. So I was finding myself really just sacrificing print speed just in an effort to get this thing to print reliably. And so this is what I ended up with. I also had to make the shell a little thicker than I was hoping. I was originally trying to get away with making it 1 millimeter in a lot of places, but here it's mostly 2.5 millimeters, at least on the sides. That bottom face that prints against the print bed is 1 millimeter in most places, with a couple of support braces. But yeah, I've been really happy with this new printer camera setup. You can get a lot of good, sharp detail where stuff is actually being built. It's just like a network security camera, basically, but it was pretty easy to get it going with Octoprint. It just needs something that knows how to take a JPEG over HTTP, which these do. I really like the little castle bits on top where the two halves of the shell connect to each other. Anyway, thought I would share that while it was handy. Okay, we were changing the scale on the derivative gain. Is this the right version of that mount? Come on. Okay, yeah, it is. Doc. Okay, maybe we can actually edit the file this time. That would be nice. Yay, we can edit the file and make it fail. Okay. Oh, fine. Let's just do 0.1. That's probably still way too much. I feel like this is this like vermouth or something? Is this like, you need just almost none of it? I mean, there's a reason people often make controllers that don't have the derivative gain at all. It is sometimes just too spazzy to be useful, but let's just cut this down by a factor of 10. Yeah, that's not good at all. I mean, the derivative gain is supposed to make it respond faster, so like twitchiness is going to be the consequence if we have too much. That's just a super noisy PWM waveform. You can kind of hear it in the motor. Let's see if I can get some of the camera back so you can actually see this stuff moving around. This is not bad. Oh, see, that sounded terrible. Is that... Maybe the integral gain's too high, too. See, that looks so much smoother, just even from this little tiny graph. "3D print a collar for Tuco." I don't like to have Tuco just wear something all the time around here. He's got a collar that he wears when he's in the hallway, and I might need to track him down. Okay, I think we can just put these gains aside for now. I could fuss with these, but I don't need to right now, and they're easy to fuss with later. So, this is the other thing. I mean, we've got these parameters, which I mentioned. We don't really need to mess with these right now. I think they're a little more self-explanatory than the gains. Sometimes it's nice to mess with especially the acceleration rate, but I think I've got that set all right at the moment. So, this thing is pretty much completely new. I made this yesterday. This is a little workflow for calibrating the sensors in a winch. So I did a pretty hasty calibration yesterday just to get everything swapped over to the new SI units, because of course everything kind of broke when I did that. But now that that's there and I have like a basic calibration, I figured maybe we could do a better calibration here. And so this is all in this winch calibrator file over here. So let's take a brief look at the code without that overlay. So the calibrator is really a system for kind of working you through a step list, and some of the steps involve recording measurements, and then it's kind of like a worksheet. It's like you're doing some things, recording some data, and then at the end you can do a calculation, and if you like the results, you can save the file. So that's kind of how it's designed. And so the highest level component here, and just in case you're not familiar with what this even is, so this is a web front end for controlling the bot, which is what you're seeing here. It's written with React, so pretty industry standard, also pretty overkill for this, but kind of nice to have in some ways, and it's been a good excuse to learn it. And so these are ECMA script 6, like modern JavaScript files that get compiled by Babel and Webpack into small browser-compatible JavaScript, which gets served out by the Rust server. But then there's an alternative flow where you can run a development server that does that compilation dynamically, like in the server every time the request is loaded and then cached. And so that's what we're using right now. So, and this JSX stuff that we're writing in is kind of an extension to JavaScript that supports inline HTML-like syntax like this. So it's typical for React apps. And so we have this winch calibrator, which is a component on the page, which is pretty much everything below this navigation. And so you can see it starts with this calibrate distance sensor heading. And then we have the graph, so 2 graphs just to show the current sensor values. That top graph is showing the position, but it doesn't really do much when the sensor is idle. The position sensor is not noisy like the force sensor is. And then we have these two calibrator objects, so a distance calibrator and a force calibrator. And those are both actually subclasses of the same base class. So here's the force calibrator. Get rid of that trailing white space. And so it adds a current measurement function that takes the model, that same JSON-ish data model we've been working with, and grabs the latest data. It also has a function to kind of do that final calibration and kind of take the entire worksheet and figure out what the calibration is. And then it has, it just has some HTML to display the checklist. But then each item in here, so you'll see first it says, so this is the force sensor calibration here. So it says temporarily adjust the filtering, likewise temporarily adjust the filtering. Then we have this inline slider, which is just another component that can edit the configuration. So we can just drag this around, and the goal of this is normally when the robot's operating, this wants to respond pretty quickly to changes on the force sensor. But to get the most accurate reference points, we actually want to really slow this down and just eliminate all this oscillation, for example. And so this is why like digital scales will take a couple seconds to give you a reading, because they need to filter out all this kind of noise in the data. So we can do that by kind of playing with this filter parameter and getting it dialed in so the noise amplitude is just pretty low. But you can see that if I do that and then I go and actually, like here I go pulling the cord down, and now it actually takes a while for this to settle. So hence step 2, the filter should take several seconds to settle in this mode. Maybe that's a little too extreme even. But so yeah, maybe somewhere around there. I've also got a button at the bottom to revert that particular parameter. But then, the middle of this really, like all of this, this is a bunch of instances of this measurement button. So I have a step, I get a record button, so you can click that to record, a 0 reading, and then later on the actual reading will show up, so I have another function to do that. And so the list of steps is different for each type of calibration, but then I separated out the logic of just having a checklist of measurements into this base class that I just called a calibrator base. And so the calibrator base, it's using this kind of weird, slightly obscure React feature called contexts in order to get access to the current connection to the robot, because that's just something that so many of these components need access to, and I didn't want to have to plumb it through manually. So if you're familiar with React and React Router, it's basically the same way that a React Router and its routes communicate. So that, there's this very top-level object that actually manages the connection, like a singleton, and it passes this instance of itself onto any clients that want it. So we get that. We can make a measurement button, which, it has some state that tracks what measurement we're on, so that, as you go through this flow, you can click record and it measures that. And this kind of activation state follows you down. You can't jump ahead, but you can jump back if you want. And you can just keep redoing a step if you want to. So that's what this logic does. It's got an on-click handler that saves the measurement and sets the state. Yeah, and then once you get to the bottom, like if you actually fill this out, just give it some terrible data, then it calculates the new calibration, gives you the JSON that it would be sending to the server. If there was some problem with it, like that, then that's also how it reports errors, because I was lazy about designing this whole thing. But yeah, if you change this, then you can see it changes the calibration. And then if you clicked save, then it would actually write that to the robot, which I wouldn't want to do if it was this far off. This will affect the motion control now. So the force calibration is used for figuring out if the force is within limits, as you'd expect. The distance calibration, which is done up here, that's used for the PID loop. So I suspect the way I'm going to have to bring up new winches is to just copy the PID loop configuration from a different one. The way I brought up the system, like before coming up with like yesterday's calibration, was I was using calibration coefficients of 1, and then I just had to completely change all the gains once I actually created the first real calibrator. But I have to be able to move the winch around to do the distance calibration. So I need like a temporary calibration for that. I might add like a direct PWM control mode, but that doesn't seem like something I want. I think I'd rather just use a temporary calibration. Anyway, let's actually go through this. So we need some way to control the winch. This is offering us a link. Actually, this already opens in a new window. This is offering us one of these in case we want it. Which, maybe we should have the camera. Oh, I think that time I just dropped it fast enough I got a voltage reset. Because I didn't have the acceleration ramp because it hit the PID loop watchdog when I released it. That means I need to do some tuning, but it's fine for now. Okay, so I'm going to close that because I've got this, but if I didn't have that, I could use the on-screen joystick. Okay, so I'm going to record the reference with the toolbox pretty much not touching the ground, of course, but close to the ground. So there's the reference. Now I need to actually make a physical mark that I can watch move 1 meter on a measuring stick. I think when I say measuring stick, I actually mean a measuring tape, because that's what I have that's actually long enough. I think I might also change the camera angle a bit. All right. So I just want this to be lined up with the front face of the winch, and try not to have it fall over all the time. It could also potentially be nice just have another length of string that's a meter, but that would stretch. Last time I did this, the winch was not even an angle like it is now. Let's just tape this to the front of the winch. Electroneum is saying neural network PID tuning, but then how do you tune the neural network? You need to actually straighten this. I've got the winch at a weird angle right now. is a little more in the way, but that'll do. Okay. Like a horizontal brace. Let me just lower this down. Which means I need to raise the toolbox a little so I can give myself some room to do that. Okay, so now I can tape this to the winch and to a point above the winch and try to get it parallel. That is probably as close to parallel as I'm going to get it on this particular setup. Okay, and now a little piece of tape to mark the position. Can I get the camera any further back? Pardon me, I need this to be full screen so I can focus the camera. Okay. So I think I'm going to use the 130 mark and the 30 mark on this tape since they're a meter apart. And yeah, I don't know how accurate this needs to be in practice. Probably not, especially because it just kind of controls how realistic our units actually are. But it'd be nice to at least try. So that's 130. Let's make sure we've still got that recorded. Cool, because I did actually move it. So now I need to move it 1 meter. It doesn't matter which direction, it'll just take the absolute value of the motion. Oh, I need to actually move the toolbox up if I'm going to start that way. Okay. Again. Okay. Little tape mark. New reference. Parallax error in the measurement. It is tricky to move it very slowly with this joystick because it's hard to tell exactly where the dead zone is. Actually, one thing I can do to make this a little easier for myself is to turn down the controller speed. Let's try that. All right. I might change how this calibration is done because it's much easier, I think, to measure how far it did move than to move it a specific amount with the current setup. Oh yeah, that's nice and pokey. It does make me wonder if I could have better luck doing a control loop where the feedback is done based on position rather than velocity as it's done now. It's just that for the most part, like for the flyer, the position as reported by a single winch isn't really that meaningful. Velocities mean a lot more to the flyer. All right, now it's got some data. How does that compare to our last calibration? Uh, 2817. That is somewhat different. More inclined to believe this one because I did the other one pretty hastily. So, all right. But we can combine that with maybe some future data points later. So that was the distance sensor calibration. Let's try the force sensor. Okay, so we need to make sure that the filter is set to about the right level. So, you know, we were still getting some vibrations, but the magnitude is just super low, so I don't think we need to worry about that. This is about the right rate, I think, for settling. Okay, so first we want a 0 reading. So it wants to know 0. Okay, so now it wants an arbitrary weight, which in this case is going to be the toolbox with, I guess it's got some bearings in it right now. But let's at least open it so I can add stuff easily. That's the reference weight. Okay, now a known additional weight. So I need one of these spools of wire. I don't have like a calibration weight that's big enough for this. I think I've got one that's maybe, I think maybe this, well, I'm about to get out a little scale. I think it might have came with a calibration weight, but it's probably like 2 grams or something. So I think instead I'm just going to measure something arbitrary. Oh, now I kind of want this on camera. This doesn't matter that much. This is just a basic, this is 4,000 grams by 1 gram, so this has plenty of capacity. I think it's got enough resolution. Actually, that spool of wire is only ½ a kilogram. I think I want something in there that is kind of substantial just to give me a bigger difference to measure over. Here's a different spool. That's also about ½ a kilogram. There's a bigger spool, I think, that was 1½. Will that even fit in the toolbox? The cats have been so quiet. I can only imagine they must be sleeping upstairs or something. Oh yeah, that's bigger. Yeah, 1494 grams. All right, and so I've got to put that in, let it settle, record that. It's also possible this doesn't fit in the toolbox and I have to find a different attachment method. Yeah. Let's try this again with a bigger toolbox. This weight is pretty arbitrary. It just needs to not put the whole system over its capacity, which in this case is about 5 kilograms. So, yeah, let's just have an entire toolbox. You know, this is a really inconvenient shape though. Maybe what I want is a bucket. Oh, there's Cloud. At least I can get the cat back on the camera. Alright, it's a bucket. Because buckets, right? They're on everyone's list. Or is it the other way around? Okay, these pulleys are also kind of annoying. They really need, like I've already printed 4 of them, but I think I might reprint them anyway because they're just way too easy for the cord to come off of. I think they need a deeper groove. Electronoob says put Tuco in. Oh man, I don't think he would stay in there. I think he would just jump right out. I don't think he'd like that. Also, he's pretty heavy. He's like 14 pounds or something. 12 pounds maybe? Still, he's a heavy cat. I don't know what that is in kilograms. It's a bucket on a rope. That's pretty great. I'm gonna put the bearings in there too, because it's pretty light as it is. A bucket on a rope with some bearings. So, just for fun, I'm gonna see if the 0 reading is still consistent. Pretty close. Okay, now we've got the new reference weight, just the bucket with the bearings. Great, and so we measured our spool. We haven't taken any wire off the spool, so that weight should still be good. We just have to put this in the bucket. That looks settled. Now we take it back out of the bucket. I just wanted a few samples that I could average, you know. Maybe stop it swinging. Yeah, bucket exercises. That's what I wanted to do. I'm actually pretty happy with the way this calibration flow works. Like, it's hopefully not something I have to do a whole bunch of, but I find it super satisfying to have it be easy to redo so that I can, you know, if I need to debug it for some reason, if I need to change it, it's just easy for it to redo. Otherwise, like if I was doing this all by hand, it would be super annoying and it would be error prone. Oh, right. Now it wants the 0. Actually, I should stop that from swinging. Ha! That's a nice view of the damping. Okay. Now the last 0. Sweet. So this is the average of the two zeros, and this is the average force per unit in the sensor. And then it's also reminding us to revert the force filter. Okay. So now if we go back here and reload the config file, we should see the latest. Is that right? Yeah. Cool. And we should be able to use this as a weigh scale now. At least pretty roughly. So if we go back to sensors. Yeah, so right now it's between 1.1 and 1.1 kilograms. It's pretty tight. We should see the 0 be pretty reliable. Yeah, that's pretty 0. 1.1. So what do we expect to see if we, let's see, how much was this again? It was like $14.95. So we would expect to see like $25.90 or something like that. Plus some oscillation. Let's see what it is when that oscillation clears. Maybe like 2.69 or something. That's not bad. All right. So that's calibration. And we'll need to do it to the other winches, of course, but this is the first. There always has to be a first. All right, we won't mess with the PID especially more right now. So I think that's pretty much it as far as what I wanted to show in the software and stuff that we can do with the parameters right at the moment. I think the next thing to do is to put some LEDs in here, because it needs LEDs. It doesn't need LEDs, but I think it would be great to have some LEDs to show the modes and just generally how the winches are feeling. So, can I not Control-C this? There we go. What did I change in source? Oh, just some trailing white space. changes ready to check in. Okay, well, let's bring the winch over to the desk and take it apart. Not completely, but just a little bit. It would actually be nice to unwind most of the cord from the winch. Actually, that's not true. I don't think that's necessary. It might even be easier, actually, to just wind it completely. So let's just do that. I'm going to take the bucket off. If we were disassembling the mechanical part to the winch, we would want to take the cord out just to make our lives easier, but since I'm only working on the electronics and the shell, it's easier to just have it fully wound, because that also keeps it out of the way. All right. So right now, actually, the winch will not, well, the winch won't try to let out any more cord. It will actually try to take it up, which isn't necessarily great when it's this low on force. So we should give it a little bit of a load, but let's try that. Let's turn that rate back up. I don't want to lose this in the machine. There we go. Now we can unplug it and bring it to our healing desk. Let's move the camera back to its arm. There's some cattail waggling over there. Oh. Okay, let's put this down. Alright, back to desk mode. Kind of. Mostly back to desk mode. There we go. Cool. Alright, here's our robot back from roboting it up. So if you haven't seen this thing together, this is a pretty nice view. Let me make that a little bigger. That's not a bad view either. That's Cloud. He's the super big puffy cat. Alright. This is WinchBot. Power supply is a little warm on the back. That's where it keeps its big MOSFET. So you can see on the back, we've got power in e-stop on the front. There's network. One mounting surface is this kind of arc back here, and then the other is this threaded rod that sticks out. So you kind of twist this bottom piece on, and then the top goes on with a little thumb screw. It's got a face. It'll look even more face-like, I think, once it's illuminated from the inside. And it's got a little e-stop you can smack. Looks like it just had a haircut. And so on the left side, well, I'll need to take both of these off. Let's just take these both off. So the left side has mostly the power electronics, and the right side has the microcontroller. Oh, let's maybe have manual focus. With a face like that, it needs a better name than winch. Aww. Yeah, well, the other name I was toying around for these was calling it the spool pig. Because it looked kind of like a pig with little feet and like a big old nose. But then I changed the design a little bit and it looked less pig-like, so I stopped calling it the spool pig. But that's kind of an okay name too, maybe. So each half, you've got these 4 screws that anchor down to one of these 2 brackets. I'm also just evaluating how warm this stuff is. So the power supply puts out a little bit of heat. The motor controller is cold. The capacitor, I think, is just picking up a little bit of the heat from the power supply. The motor is like kind of buried in the very middle under all this stuff. So, and then inside, most of this is just reinforcement. It's got these little sort of castle-y nubs that interlock, so the 2 halves fit together. I can demonstrate that with the other half in a sec. So this will flip around. The guts of this winch bot are actually somewhat substantial. I haven't actually weighed this whole thing, but I guess the winch bot is a little bit heavier than that toolbox full of bearings, because it wasn't lifting the winch bot off the floor. And I think the toolbox full of bearings was a little over 1 kilogram. Alright, and then here's the other side. Yeah. This thing's been doing alright. It's warm, but not in unexpected places. And so you can see what's been making all this tick. We've got big old 24 volt, 150 watt power supply taking up most of the bottom of this. And then inside it you can see just the end of the motor gearbox. The motor is, as you'd expect, kind of right in the middle, and the shaft comes up to this gear, which I won't touch because it's covered in lubricant. The 2 gears are made out of semi-flex. So they're 3D printed, they're nice and quiet and seem to be strong enough. And then that drives this, which is mounted with 2 bearings. And then the cord goes through this whole Rube Goldberg apparatus. So I've got, I think this is the roller that's been making noises. See that? That's a problem. So I think that's where the creaking's been coming from, but we'll need to take a closer look. Oh, I totally agree with Bob's picture there. Yes. Ride the pig. See, these have been fine. More rollers. You can see a little bit of wear pattern, like a little bit of rubbing on the center, but they're fine. And then this roller is just barely tall enough, but so far it hasn't quite been worth redesigning it. And then these 2 rollers actually probably suffer the most friction of all of them so far, because they're just kind of intentionally tensioning the cord a bunch. It might be worth, if I was redesigning this part, I might want to spread these out a little further. But I think it's fine the way it is. It certainly hasn't been causing problems. And then the very end of this is actually responsible for the measurements we've been making. So this piece right here is the encoder. And so you can see, like, the encoder itself, it's manufactured with an integer number of stripes on its optical wheel. So there isn't really much to calibrate about the encoder itself. Like, it's got a very reliable way to convert angle into count. But the thing that we need to calibrate is, like, basically what the average diameter between the center of the cord is and the center of this, which depends both on the shape of this capstan, but also just on the geometry of the cord and how much it stretches and flexes during this thing. Like how much material is above the center line of the cord when it contacts this. And so that's something that seemed easier to calibrate for than to try to calculate. Fred asks if that means the flyer needs a green fabric wrap. That's totally possible. I left room in the flyer for basically a like semi-cylindrical kind of wrap around the center part that I have not designed yet. So there's certainly room to decorate that. I've been trying to figure out like how to incorporate the Tuco Flyer logo into the flyer. And that's actually been really difficult because it doesn't have any big like horizontal surfaces that are visible. But it certainly looks great on the web UI, so it's been nice to use it there for sure. What else is worth going into here? So the mechanical stuff is probably pretty self-explanatory. Certainly ask questions if it's weird, but. And then over here, this is the little TI development board. These are $20, which is why I'm using them. It's a really inexpensive way to get something that you can do real-time motor control and Ethernet on, which is kind of what my requirement was. And so it's actually a little ARM Cortex M4F with, so it has hardware floating point. So all the motor control is in floating point, and it's just fine with that, which is pretty nice. I'm still used to implementing stuff like this in fixed point math, so it's kind of nice to just be able to use floats and then have arbitrarily slow velocities in the system. So there isn't really anything behind that. That's just, so there's the microcontroller board, which, it has peripherals that do all the things we need basically, except for actually driving the motor and then amplifying the strain gauge sensor. So this is the force sensor. It's literally the same thing you'd find in a digital scale. And it's connected to this amplifier chip, which is also the same thing you'd probably find in not necessarily really tightly integrated digital scales, but if there's a digital scale that has a general purpose microcontroller in it, it might have this chip in it. It's the HX711. And it's actually a 24-bit A to D converter. That's what's been generating the values we've been looking at. And so that goes down over sort of SPI to the micro. And then on this side, that just leaves the power electronics. So this is the big old capacitor that stores any extra energy we have when decelerating the motor. And if this goes over voltage, then the power supply shuts off. And there's quite a lot of margin in this capacitor, so like parts in the power supply are going to start to die before parts in the motor controller or the capacitor are going to be at issue with this. So having such a large capacitor lets us store a lot of energy without raising the voltage that much, which was kind of the relationship I was going for. This is 4,700 mics at 63 volts. And then this is the motor driver, and it is way overkill for what we're doing, but I was using a much smaller driver, which I'm spacing out on the part number, but it was only rated for, I think I was using 2 3-amp channels in parallel. So it should have been able to handle like 6 amps, but I think there was just some transient that it couldn't handle, or some overvoltage or overcurrent, and it just popped. So I was like, I think I need a different driver. And so this one is, this is something by Infineon, and it's way over-spec'd. Like I think it's rated with proper heat sinking at something like 40 amps. And my motor, I've only ever seen it draw like 4.5 amps max, so. And the power supply here is rated at what, 6 amps? Yeah, 6.5 amps. So, yeah, the whole thing is pretty beefy, and it's it's of course a 24-volt motor in there. So, we'll be looking at this again because we need to wire in power and data for the LEDs. Let's take a look at the shell. I'll put this aside briefly. It is satisfying having a fully assembled winch bot on the desk. It's a lot of parts that fit together nicely. So then to kind of demonstrate the shell, oh yeah, it's got these great interlocking fingers. So the thing was, this is all held together by these 8 screws. So 4 up here, 4 down there, all kind of compressing the shell onto that inner core. But then separately from that, I needed a way to keep this edge together, because otherwise, you'd like press on this and the two would like flex separately from each other, which would make it feel really not solid. And it would also mean that like when the cats jump onto it, then the shell would just kind of start breaking apart instead of staying solid. So let's see if I can get a view of that structure, because I'm pretty happy with how this turned out. Yeah. So you can see how the outer edge here, so this edge, this is like some particular thickness here. I think this is like 2.5 millimeters. Originally it was even thinner, but I had to make it thicker for printability once this thing got so far away from the base, basically. So this edge actually could be thinner if you didn't have such a hard to print part to begin with. And then it's subtle, but there's a little bit of a chamfer where the thickness increases right around the joint to, I think, like 3 or 3.5 millimeters. And then it also splits. So once it gets thicker, then it also splits into an outside surface and an inside surface. So, and I'll open this up in CAD also and overlay the footage together when I'm editing this, because it's certainly much nicer when you can see the physical object and the CAD model at the same time. So it kind of splits into 2 pieces where you see there are these fingers on the inside that alternate, but then on the outside it's just kind of it looks like a continuous surface once it's fully assembled. It would look more so if this wasn't translucent, but. And then when you press on this, the interlocking fingers actually keep that joint together. So I'm pretty happy with how that turned out. That was like one of the riskier parts, because like I designed this thing, which I could not test until 2 of these fully print, which took me a while to accomplish. When everything works out properly, printing each half of this takes a day, and there were a lot of problems I had to debug. But yeah, I'm really happy with how sturdy this overall thing is. So there is an additional feature that these shells have that we have not been taking advantage of yet. They have a spot for LED strips. So there's actually a bunch of LEDs going into this project. Partly for utilitarian reasons, like for these winches, I want some status indication, and it seemed like a strip of RGB LEDs would be a nice way to do a lot there. And partly for fun. And same on the flyer, it has a bunch of LEDs. In fact, it has even more. It has a lot of these LED rings that I built earlier. And these are great. They are going to partially serve as kind of human interaction. So what mode is the robot in? Where is it going? Things like that. But also I thought it would be nice to look at. So. Let's take these screws out. I hadn't totally decided on what kind of connectors to use here, since I would like to still be able to take the shells off easily. The LEDs themselves I'll want to glue into the shells so that they stay put. So ideally I would have a connector between the 2 halves, because I'm going to have to daisy chain these LEDs. The wiring will go from the circuit board to one LED strip, then from that LED strip to the other one. I don't know if I have enough 4-pin connectors for this, so I'll have to check my stash, possibly improvise. So that's what this channel is for. There are a lot of birds happening outside. I suspect Tuco is into that. So here I'm putting the input on the bottom. That's probably what I'm going to want to do since the control board is at the bottom here. And on one side I'll probably have an output wire kind of looping right back down along the edge of this. So the slot here is not really fully enclosed because I wanted to avoid an unsupported overhang there when I was printing it. So it's actually like a fully, can I avoid describing this and just get an in-focus picture maybe? Yeah. So it holds down the LEDs at the bottom, but not especially at the top. That's partly what I'm going to have to glue it in for. But I figured that was a good compromise between making it printable and actually making it hold. I figured this plus a couple of globs of hot glue or epoxy would do just fine. I might use a little bit of epoxy there because it might look better than hot glue, and I don't want to have to deal with strings in this project. But before gluing it in there, we should do the wiring and test it. There's one strip on this side, facing in, of course, to illuminate all the innards. And then same thing over here. So, I think I need to rummage around and find some cables, or some 4-pin connectors if those are available. So maybe this is a good time to use this view. It's almost like an instant replay. Like when I push that button, the camera has enough of a delay that you can still see me reaching over and pushing the button. You can see the cats wandering. It's so dark in here. Hey, Luna. So a lot of LED strips come with stuff like this installed. These came off of, I think, the same LED strip that's going into here. So, you know, they'll have 2 wires for power, and then some daisy chainable wires that you can use. This is pretty nice. I like it. I don't have enough of them for all 4 winches. So it might be worth ordering something like this, but it's just such a small thing that I'm tempted to improvise, but we'll see how bad of a solution I have here if I don't end up having to get something. I also have a somewhat larger quantity of these 3-pin connectors because I've been doing more LED stuff with the WS2811 kind of, you know, NeoPixel style LEDs. But these are not super useful for the APA 102s that also need clock and data, not just a single data wire. So they're also just pretty bulky, so I'm like, I haven't decided how much I care about keeping the wiring for these kind of aesthetically unobtrusive. And so what I often do in these projects is I'll use silicone wire with white insulation near the LED so they don't add a bunch of color to the LED light. That's why I have so much white insulated silicone wire around here. So I think I'd be happy taking care of the wiring myself. I wonder if I have any JST connectors or something else that I could crimp. Oh, I think Luna's interested in the birds. Hey, Luna. Oh, we don't have a cat overlay on this screen. I think we need a Tuco cam. Why don't we even have a Tuco cam here? Let's copy and paste a Tuco cam from elsewhere. Not from here. Can we grab this Tuco cam? Copy. I don't want to cover up anything interesting, but oops. That was disorienting for everyone, I'm sure. This corner is not super interesting. This corner is all blank. Let's put it up there for now. I just wanted to show you Luna because she was being really cute. I have some of the parts for doing this with JST style connectors. I've got these 4-pin housings and the crimps to go into them from a different project. I don't know if I have enough of the receptacles, and they're not like wire crimp style receptacles, they're surface mount receptacles. I'll show you what I'm talking about. Ah, she's so cute. Yeah, I could use something like this. It was really tempting just to use 0.1 inch headers for this. And I have a whole bunch of those kind of low quality jumper headers, but I'd like to avoid using those for power and ground, especially because I've determined that that wire is definitely not copper. So just have to keep going through my junk. I could also wrap up this stream and order something proper, but you know, where's the fun in that? What are all these? There's some other weird stuff here. These are a bunch of parts from infrared illuminators, some of which I disassembled and used for other stuff. So I've got a bunch of these little circuit boards that I think are buck converters. There's one side that has a 2-pin JST and one side with a 4-pin. I've got a bunch of these with 2-pin connectors, which doesn't really help. But I have a bunch of these boards, if they're actually useful. I could just steal connectors from them. So I think I have a crimping tool that can make the connectors that mate with this one. I just don't have... I mean, I have some of these, but I don't have anything that would actually be convenient to use. Like, this is not convenient unless you've got a circuit board. And I've just got wires. This is nice, but also 3 pins. Oh, spring contacts. Yeah, that could be really fancy. I did not design any mechanical parts that would like hold the spring contacts in place, but that would have been a nice option maybe. Super fancy. Definitely would have required having a specific connector in mind rather than just winging it. Oh, you know, I've also got these short ones. I have not tested to see if the short ones are as bad. If the short ones aren't that bad, I could use them, like I could splice them into a wiring harness. But they might also be aluminum. Let's test them. Everyone knows how to test whether the wires they've been buying are actually copper, right? Lighters don't melt copper. That's not a lot of wire. It may be a little better than the other ones, but... I don't know, man. Kind of skeptical of these, too. They're very thin strands. Where did that focal plane go? That, jeez, that's not copper. Okay. Yeah. I mean, I wonder if I should really just get a kit for making these crimps, because that would be super useful. I just don't have such an object. Because that would be really useful for me right now. Don't want to use these for powering the LEDs. Yeah, you see that? I was melting that thin aluminum. And something was sparkling. I don't know what that was. Shall we try a bit more, just to see if I can get a little more photography of it? Maybe if I clamp this in something. Just to keep it easier to hold in the focal plane without wiggling it around. High quality copper. Yeah, there's just like some kind of plating on there, but okay. Anyway, that smells terrible. Okay, well, it's a little tempting to throw in the towel for today's stream and order some better connectors for this, since I don't really want to just solder them directly on, because it would just be annoying to not be able to easily take the winch shell apart. Take another look through my connector stash, but yeah, having a decent stash of small, like multi-way connectors like this would be super handy. I should really get something like that. I will really often use servo extension cables for stuff like this, but it's just a pity that they're three pins. That 4-pin JDC or JST, that 4-pin JST crimping kit I had was for this other project I did where I needed like all the wiring to be white because it had to be near all the LEDs and oh, what is this? Oh, these are 3-pin. These are more servo leads. And I've got some like larger stuff, like ribbon cable kind of things. I've got like just like some random 4-pin like sound card audio connector style thing, but I don't think that would be good for this either. Here's some 3-pin Molex, which is kind of overkill for this, but is much closer. Still 3-pin. You know, I guess we could turn this into a connector shopping expedition. Pull out a couple of representative things here. Oh. Well. Here's another random set of like breadboarding leads. I'm curious if they have the same problem. A lot of them that I have came from the same source, so I would be surprised if they were different, but I wonder if these are different. These are male on one end and female on the other end, I guess. Probably should sacrifice one to figure out if they're actually worth using. If they were worth using, would this be enough? I have 4 winches. They each need 8 of these, so no. So maybe they do feel more substantial than the other ones, so I'm less likely to just like want to sacrifice them immediately to test them. Maybe I'll just put these aside. Well, you know, what am I saying? I'm never going to use these if I don't trust them, so I should really at least take one and sacrifice it to see if they're actually worth using. Yeah, let's take the brown one off the end here. Very thin wire. It actually looks kind of similar, honestly. This might still be aluminum. Let's find out. Maybe the extra substantial feeling was all in the insulation. It's always a bad sign when the insulation doesn't seem to have printing on it, which is the other thing I was looking for. But sometimes you see that with ribbon cables because they're printed in like one spot and then you can tear them apart into individual cables. Oh nice, Ellen might have the right die for her crimper. That could be useful. I think right now it's not just the die, because I think I have the right crimping tool for the JST, like the JST receptacles that you see all over the place. I think I have that. I just don't have the right kind of mating connectors. I think I have a strip of surface mount mating connectors. I don't even know if I have very many of those. And then I have those boards that I found that are probably like lighting DC-DC boards that I could desolder some from, and those are through hole, which might be a little easier. That might actually work, honestly. Desolder those through hole connectors, treat them, like just solder the through hole pigtails directly to wires and put E-shrink over them. That might actually work. I could just do that. Let's burn something first while we think about that. But yeah, maybe that would just work. Oh, I started the oscillation again. And that is not copper. It looked like it was burning. Like maybe this is iron. Could this be, I mean, is it magnetic? Where's the closest magnet? Well, what do you know? That would have been an easy test, huh? Man. I wonder if any of the wire I've ever bought on eBay has been copper. I mean, it's probably better if you're buying from places that are like specializing in wire. But stuff like this, ugh, that just shouldn't, that's not right. This is so sad. Okay, well, so let's not use that then, because these are in the same category. While we're testing wire, I'm curious about these servo extensions, because this is something else I've often used for this purpose in projects, are these cheap servo extensions. These also I bought just because I wanted, like, I needed just a bunch of them from some project, and didn't care that much about quality, so I tried just finding some really cheap ones. So these look less sketchy though, like the wires are printed. These actually say 300 volts, 26 gauge, 50 degrees C, which they wouldn't say if it was like iron, I suspect, but let's try. Let's see what we got. Oh, there's a lot more metal in there. There's just more to the wire. This would be super convenient to use if I was not using API 102s in this project. If I was using one-wire data LEDs like the WS2812 NeoPixels, this would be great. Oh, look at how much more wire there is there. It doesn't mean it's actually copper, but at least it's not magnetic. This might be all right. So this is one of the wires from a servo extension lead that I got somewhere cheap. Oh, look at that. It didn't melt over here because I guess the wires were kind of bunched together. Let me see if I can separate those little. And we tried this earlier with some just very fine stranded copper wire and nothing. I could repeat that experiment if you want. Yeah, there we go. So, if we tried the same thing with some really little copper, like what do I have that's little? I have some 40 gauge over on the other side of the room. Maybe some small stranded though. Where is the nearest wire that I know is copper? I mean, this stuff is definitely copper, but it's also really thick. This is 42 gauge magnet wire. Let's just put those all in there together and see how well they fare as a group. So, you can see the size is pretty similar. This is not very scientific, but oh yeah. Well, that's interesting. Why did that melt? Am I really sure this wire is copper too? That's concerning. It's always nice when the control experiment goes according to plan. Wow. Is it possible this wire is not copper? A good experiment. Or is this just not? Let's try something else. Let's just keep burning wire, why not? Maybe some thicker. This is still a magnet wire that came from the same supplier. I thought this was good stuff though. Let's try this. This is 30 gauge. I didn't intend this to be the burning wire channel, but why not? No, that's balling up now too. You know, have I been misled? Is this just like not a good test to perform? Maybe we need to do some research on this. Oh, interesting. Jarrett has experienced this with very thin copper wire too. Well, so is there a better test we can use? So obviously the stuff in those first jumper wires was not copper because it was magnetic, but yeah, it also seems like maybe this test is not actually working. So can we do some research on this? Okay, so there's testing the resistance. There's some random people on YouTube. somebody debunked this. Is it real? Copper clad aluminium. Oh, fluke. Interesting. So they're scraping it. All right. And resistance testing. So what about the lighter thing? This is not what I'm looking for. Let's just see how much the search engine can do here. Oh, 1970C. Really? That is really close. Yeah, I don't know what to make about this. It doesn't seem like copper should melt on the lighter, but it also seems like it's close, so maybe there's some effect that causes it to work out when the wire is super thin. It could also just be that all this tiny wire I've been using is actually aluminum. Can we try scraping it under a microscope? Will that help us out here? Microscope. Okay. This stuff right here that I'm about to put under the scope is the copper that we just successfully burned with the lighter. Just to make sure I'm not just going crazy over this, let's just make sure. Let's light this again. Can I focus the microscope that high? This wire is so thin it just stuck to my fingers and I didn't even notice. That really messed up the exposure, didn't it? Definitely melting. Let's try scraping it. I'm not super concerned about the validity of this wire so much as I just want to know if this is a good way of testing, because I've been trying this and it would be nice to know how much of the wire in my shop is actually copper-coated aluminum and maybe get rid of most of it. I find the right size thing to put this on so that it's in focus. Maybe I can... I just don't think I can cut it directly on this mat because the mat is really squishy. Maybe this. We want more magnification. That much. This is a very little wire, if you haven't noticed. So can I get a finger in here for reference? So if we scrape it, we should see the varnish, which is kind of this super orangey layer, come off, and then reveal copper underneath. And There's still a bit of metal attached to my knife. And not see like aluminum underneath that. I might need to use a fresh knife blade. This one's looking a little gross under the microscope. I should definitely get in closer though. Oh, there's the shallowest focal plane and the shakiest stand. I had this microscope stand optimizing a little more for getting out of the way than providing the steadiest view. I might have to scrape it a bit and then focus it. I wonder, is that looking too shiny? Huh. It's kind of hard to tell, but that looks like it might not be copper. Wow. I think maybe the 32 gauge wire was fine though. That would be interesting if the different gauges of wire from the same supplier, like one of them was counterfeit and the other wasn't. What can we tell? Oh, there we go, more light. That doesn't look like copper, does it? Wow. Okay, can we get a side-by-side comparison if it's possible? So that's the 40 gauge. Yeah, 40. This is 32 that I'm about to put on. Okay, there's the 40, there's the 32. These wires really look enormous, maybe. Well, I don't know. They're really not that big. I mean, 30 seems enormous now that we've been working on the 32 seems enormous. Did this manufacturer think like, oh, I wouldn't notice because it's varnished? Is that copper or is that tinned? I mean, I might expect a little bit of shiny metal on the outside because it would be tinned. But if I get to the middle and it's still shiny like that, man, that doesn't look good. Okay, let's grab another piece of wire for comparison. Is anything in this shop copper? Clearly this stuff is copper. I got this from a reputable source. It's just bigger, so I've been assuming that like bigger stuff I couldn't necessarily heat it up even if it was lower temperature. But I'm just going to try taking one strand from this 20 gauge wire I've been using. All right, so that is 40 gauge again, 32, and then a single strand from the 20 gauge. That certainly looks coppery, doesn't it? Is it a plating? It also might just be that the really shiny metal is kind of hard to tell under this microscope. I'm going to try scraping it and then changing the lighting. We can also try the lighter test, but I'm pretty sure this wire is legit. I think I got this stuff from DigiKey. Like, all the little flakes I'm making are copper colored. But it is hard to tell the difference. Let's see if we can get a better view. Maybe if we change the lighting. That view might be a little better. The top wire is still kind of ambiguous, but it does kind of look copper colored still. Maybe it is easier to tell based on the color of the shavings that we get. Let's take a few shavings from each. So first let's blow away all the existing shavings. Well, some of them. This is just water. I didn't feel the need to use isopropanol this time, although it would evaporate faster. I want to take a little sliver out of this. I might need a fresh knife blade. That looks pretty consistent all the way through. And it's kind of hard to tell, but it looks like copper. Let's cut this one. Oh. That looks more coppery in the middle than I was expecting. I mean, it looks just kind of indistinctly shiny on the surface that I was scraping. But then that edge, can you bend that up a little bit? I don't know. Oh, just a second. I guess I'll leave that there. It's going great, just wrapping up the stream. Let's see. I'm alright. Super, so good to see you. You see. Yeah, I'm still broadcasting, but getting close to being done. Okay. All right, I think I've fussed with this particular question enough for the moment, and it's about time for me to be done with this. But Yeah, this is not as straightforward as I was expecting. It's either that or it's possible that some of this beloved 32 gauge wire that I've been doing rework with might actually not be copper. But that is confusing. I'm just going to try each of these that we've been working on under the lighter just for comparison, since I haven't tried that 20 gauge fragment. Even though it's a bit bigger than the 32, but... Oh yeah, so James is suggesting it might be better to measure resistance. So it might be. So I haven't looked at the actual resistance difference, but I don't know that I know the cross-sectional area accurately enough to trust that for wires this small. And so that would be another source of error. And then also, that's another good question. Are we trying to determine if the wire is copper or not, or if it's good enough or not? Well, kind of both, but if it's not copper, it's definitely not good enough for at least a lot of this. You know, if it's just like for some kind of high impedance, low speed signal, then whatever, which is a lot of what these wires, like the breadboard kits and stuff, are sold for. But if, you know, I don't want to use these to power my LEDs, for example. And then Peter Chalusky asks, have I tried the lighter test? Yes. Let me show you. I was about to do that again, but I would actually, if you're familiar with that, I would love some more background on the conditions under which it's valid, because I was having some second thoughts after putting some 32 gauge wire that I was pretty sure was copper under the lighter and having that ball up into a tiny sparky mess also. So yeah, like if you're just tuning in and you missed the lighter test, let me do it again, because I think it's worth trying. Let's go back to the desk camera here. All right, so I've got a lighter. And so here's a few wire samples, which I might as well put them back in the vise here just so I can get a good focal plane. I'm just really irritated about copper-coated aluminum. It's just such a terrible thing to use for electronics. And I mean, it wouldn't be so bad if it was always sold as such, but it's just really annoying having to be so skeptical of all the wires I buy. It's understandable, like it's a lot cheaper, I get why people do it, but... So, we've got a few samples here. We have some breadboard leads that seemed kind of not so sketchy. No, these aren't breadboard leads, these are servo extensions. So these seem like they might not be that bad. They have markings on the wires like they were actually like intended to reach some kind of specification. And then we have these kind of awful breadboard leads, which are definitely aluminum. So let me show you one of these first. Okay, so these are the really cheap, like, probably, I forget exactly where I ordered them from, but somewhere without a lot of quality control care. See that? They're like lighting themselves on fire. And actually, I think the reason it's burning so aggressively is that this is iron, and so we're basically burning like steel wool. I had a magnet here. Here they are. So yeah, wire should not do that. This is not something I would want to use as wire. So those are out. I still have a bunch of these. I might use them for low speed, low current stuff, but they are not something I would treat as copper, no. Oh, that's interesting. Jarrett suggests try feeding a bunch of the thin wire into a flame and see if the resulting ball looks coppery. Guess I could try that. So the next wire, so that was the breadboarding lead. The next one is the servo extension cable, and this is the one that had the marking on it. It says, what does it actually say? 300 volts, F, does that say FU? No. FN? I don't know what that means. 80C, okay. Not great for insulation, but it's like nice that it has markings, right? Okay, and so these are not steel, which is nice, but I think these are probably aluminum. That other stuff was definitely steel. That was easy to tell. Copper shouldn't melt this easily with a butane flame. Or, yeah, copper... We just looked up the melting point, and it's like just above the upper limit of what random Google answers say that butane should be able to get to. This lighter might also be running a little low, but it does seem to ball up just fine. Oh, it actually seems like it's hotter in that orange part of the flame than the blue part. That's interesting. Yeah, so I'm pretty sure that's aluminum. Smells delightful, doesn't it? So now let's look at the thin strands of wire I've been hacking out under the microscope. So this is the one that was at the bottom under the microscope. This is 40 gauge, which is the thinnest stuff I have that I thought was copper. Like, I got this stuff from what I thought was a reasonably reputable seller, but it wasn't like DigiKey. It was, I think, OEMwire.com. And yeah, and I've used it on a bunch of projects, and it seems to work all right, but it's certainly possible it's aluminum. I've never actually really definitively tested it, but it would be surprising. So, oh, this is 40 gauge. I might have said it's 32, but the stuff we're going to do next is 32, but this is 40 gauge, which is a really tiny kind of wire. So look at that. Okay, so then somebody was saying let it ball up, but then see if the ball looks coppery. I think I'm going to need a lot more. The ball looks really black and oxidized. Can we clean it up at all? Maybe we'll fuss with that under the microscope in a bit, but I think cleaning that up would need to happen either chemically or with the knife under the microscope. Okay, so that was the 40 gauge. Next is the 32 gauge, which I also got from OEMwire.com and have done a bunch of surface mount projects with, and like seemed to work all right. I've never really expected this stuff to carry a lot of current, but you know, I expect it to be good for its size, and doing tiny detailed rework with aluminum would just make me sad. That's taking longer to heat up. I think it's balling up a little bit, though. I'm trying to find the spot where it's hottest. Oh, there we go. Trying not to let it drip on my finger. Yeah, so I don't really know what that means. That seems concerning, and like this is probably aluminum, but I'm gonna try cutting into that ball under the microscope in a sec. And then one more to try while we're here, which is, this is one that I am almost 100% certain is copper. This is one strand from a 20 gauge wire that I bought from, I think, DigiKey or Jameco or somebody really reputable like that. And it looks coppery even when we chop it up. So let's see if this works. Maybe the lesson I'm learning today is that OEMwire.com isn't as awesome as I thought they were, which is sad. Oh well. I have not seen this budge. This seems pretty coppery to me. I'm just going to melt my vise at this rate. Okay. Well, let's cut open that thing that we just melted. It's probably going to look like aluminum inside. I think that's what we're determining. Oh well. This means I need a new source of wire wrapping wire, and I now have a lot of wire wrapping wire that I'm not going to necessarily want to use a bunch, which is sad. I mean, when I say a lot of wire, it's not like I've got a warehouse full of this stuff, but like one of these spools I expected to last me a long time. Like you're an engineer, son, here's your one spool of wire. Let's go back to the microscope, aka tiny vision. Where we go to the tiny things. Okay. This is our probably aluminum. Let's see if we can cut it in half with an X-Acto knife. Look at that. It's like, it looks like there's no, well, I mean, the varnish is burned off, obviously, but I don't see any, like, it might be that this isn't even copper, like, there might just be no copper in this. It might just be varnish and something that makes the solder stick, because you can't really solder directly to aluminum. At least I didn't think you could. I don't know if I can cut this in half. It's probably just going to go flying, but let's see what we can do. Where did it go? There it is. Oh, no, that's the other one. Is this it? Let's try cutting this one. That's gotta be aluminum. There's just no way copper acts like that. I mean, I think that color is burnt varnish rather than copper. I think I've maybe exposed some metal. Wait. What is that? That looks coppery inside. What is going on here? Okay, let's try resistance then, maybe. So what is the difference going to be? But man, this is just unsatisfying, because if this wire actually is copper, then that means the flame test is unreliable. And if so, I kind of want to know why, because it doesn't seem like you should be able to melt copper in a butane lighter. Fred asks if I've got an oxyacetylene torch. Not here. I've got a MAP gas can, which would work. Peter says if it holds its form, it's probably copper. It did get a little, like, a piece of it broke off on that other one I was handling, but it's kind of hard to tell what's happening versus baseline. But man, look at that. I've got this thing, like, sliced open. that looks like copper, right? I mean, maybe it's like brass or something? Could it just be some kind of really weird alloy? But yeah, I mean, you know, I think someone's pointing out, like, really, are we just checking the material, or are we checking whether it works? And so we could just check the resistance to see if it works. Let's see, how different is the resistance between copper and aluminum? Let's do a tiny bit of research first. Oh, Jarrett says, check the melting point again. Did I mess up the melting point? 1980. Oh, I missed the Fahrenheit versus Celsius. Okay. Okay. Well, okay, well, why do people do the lighter test then if it's that unreliable? Like, maybe somebody needs to do a video debunking this or something, because it feels like I've heard this advice from a bunch of people, and I've taken it at face value, and now I'm finally learning where it breaks down. No, that's not what we're talking about. The chemistry flame test is a different thing. Like, I think that this thing that electrical engineers think is real is not actually a real thing. Or maybe it's just uninformed electrical engineers like me. Okay, so aluminum should be like almost twice the resistivity of copper. The trouble here is I don't know how accurately I know the diameter of this wire, but let's just see if we can find something by gauge. So the stuff I'm most suspicious of is the 32 gauge. Like, we got that to ball up, but I've also just been using that a bunch, and I never had reason to doubt that it was copper until now. Yeah, let's use one of these. Okay, maybe just a meter. Let's see if this is something I can actually measure, though. So milliohms per meter for 32. So it's going to be like half an ohm versus... So if it's like more than an ohm, it's probably not copper. Let's just get a meter of this stuff. Yeah, maybe melting a bunch. Yeah, I just didn't have a super easy way to do that safely right at this moment, but that seems like a thing we could do. So a meter of 32 gauge. I think that's enough. I don't want to take too much off the spool because it's going to get messy. Assuming I still want this wire, but... Yeah, maybe I need to do a video on this. It's like a silly, simple thing, but I guess it seems like a lot of people might need a way to tell whether their wire is real. I'm going to leave a little extra for making the connection. Like maybe 1/8 of an inch on either side. Yes, I realize I'm using mixed units. Okay. Oh, hey, Luna. Little cat's over here. Okay, here's my test piece. It should be like 1/2 ohm. Making accurate contact to this might be a little annoying otherwise, so I think I'm going to solder it to something thicker that I can easily get my meter onto. Let's use this that I'm pretty much entirely sure is copper at this point. So I'm just going to fold this around that wire to, well, maybe it'll be easier to tin this first. Let's warm up the soldering machine. James says, "Hey Luna, back from your sunblocking adventure?" Yeah, she loves absorbing sunlight. It's probably good that one of the cats... Well, it's actually kind of nice that they're both named after things that absorb the sun. I hadn't thought of it that way before. I wonder if that was intentional. I was like momentarily worried, like, oh, this solder... Is this solder or is this wire? Because it's actually thicker than the wire I've been working with. It acts fine when I solder to it. It didn't seem like there was plating going on. Like it seemed like it was solid something. Oh, I had the biggest booger in my soldering iron. You guys don't want to see that. Nice. Fred says, just wait until they figure out how to emit that light again. Yeah. Cats that absorb sunlight and emit laser beams. Oh, Tuco and Luna are having a little disagreement over there. Copper is just such a delightful material for this kind of work. Really does deserve a reputation for being valuable. It's just a really good material. Oh, and solder joints are better when you don't make them cold, like that one on the right. Didn't actually heat up the wire, the small wire, like I thought I did. All the heat was going into the big wire. I don't know that I have gator clip leads that I super trust for this meter, so I'm just going to try doing kind of a differential test with these probes. Like I'll measure the resistance using all of the setup except for this wire and then add the wire. So I've got this loop. It's connected to these two little terminals. This isn't going to be the most accurate low resistance reading, but first I'm just going to try putting both of these probes down on this piece of copper. We have 0.2. If I spread them out, it should be about the same. That's mostly the probes and the contact between the probes and the wire. Let's see how variable it is. I can vary it by my pressure between like 0.2 and 0.1. So that's fine. That's the kind of test we need. We need to tell the difference between like 500 milliohms and like an ohm and a half. So what I would expect with this wire, if it's real copper 32 gauge, is I measure the whole setup and I get about 0.7 ohms total. Oh my god, thank you. Whoa, Zach made me more cabbage. He's so nice. Yeah, I should definitely finish this and eat. Oh, look at that, right on the money. Okay. So this is definitely copper. Yeah, Peter says to use the 4-wire Kelvin method. I would if I cared to make it an accurate reading, but what I was just saying is I don't need a super accurate reading for this. I just need to tell the difference between a half an ohm and like 2 ohms. So I think this is pretty great. Okay, so I think what this points to is the flame test is not a thing. Like, people use that, but it's really not reliable. It only works on, like, if you're lucky. Like, if you're lucky and the heating rate is just right. So, yeah, man, I should see if there's already anybody, like, debunking this on YouTube. I hate the idea of, like, YouTube debunking videos, because I don't know, I just don't like making clickbait. But if this really is a thing that would save people a hassle, then it might be nice to make a video that explains why this isn't a thing that works. And if I do that, I'll definitely do 4-wire resistance measurements and show, like, okay, here's some wire. I thought this was fake. This stuff is actually real. On the other hand, here's some stuff that is definitely fake, and just show the difference there. Since we did resistance measurements on some of this wire, not the servo leads, like these still might be real, I guess. These are still a little sketchy. But we did resistance measurements on like this stuff, or rather I tried running high power load through them and they just fell over. So this stuff I'm pretty sure is aluminum. Anyway, I will think about maybe making a video on that because it would have saved me some time if I had known. Oh cool, Peter says it's a good thing to debunk too. Well, nice. Yeah, it's nice to have that out at least. Yeah, measuring the resistance, if you know what to expect, is pretty good. Clearly it's easier with super thin wire because then you're dealing with higher resistances. And if you're dealing with thicker wire, then you probably want to invest in a real milliohm meter, or at least use enough wire or enough current that you can get a decent measurement with just a regular meter. So, oh my god, look at what Tuco just brought. Hey Tuke, do you want to play? Do you want to play while I eat cabbage, Tuke? Let me bring the camera over here. Inception. Hey, Tuco. Oh yeah, you wanted this, right? Oh, delicious cabbage. Well, thanks so much for tuning in today. It's always nice to share progress on this project. I'm a little sad I didn't get to the point of actually installing the LEDs, because I always want to do so much more than I can actually get done. I wanted to like show working on Rust code for that, but this was an alright diversion. It was worth knowing which wires are real, and I can order like the proper mating JST connectors so we can make some better wiring harnesses next time. James says, I wonder if your power supply will work as a low-range, high-current tester. Yeah, quite possibly. Hey, Tuke. I was so enjoying how pretty Tuco was that I forgot where he put the bolt. I'm sorry, Tuke, where did he put it? It's right there, isn't it? I don't know if it's coming across in the streams, but he does these amazing chirps when he wants to play. Oh, was that a bad throw, Tuke? Alright, thanks everyone for stopping by, and special thanks to everyone who hangs out in the chat between streams and gives ideas, and a special thanks to everyone who shares the streams with their friends on Twitter. And an extra special thanks to everyone who supports the channel on Patreon. That is the thing that helps me pay the rent and keep this going, and it's really helping me just invest this much time in trying to make stuff that I think you guys might like, so that's super helpful. And as always, happy hacking, folks. I'll see you next time. Oh, next time might even be as early as tomorrow morning. Might have some guests in the shop filming also, and they mentioned that it would be nice to have me working, and so what better thing to do than to stream? So we'll see if that works out. See you tomorrow, maybe. Meow.